Good morning. Today we are going to discuss about this given problem. The problem given is find the R equivalent for the given circuit. So they have given a circuit and they have asked us to find the R equivalent. Always we should remember this point. Whenever we are solving an R equivalent circuit, we should start from the right side, that is in this direction. So let us see how to solve this particular circuit. So first we have to identify which are the resistance which are in parallel and which are in series. So in this particular given circuit, this 1 ohm and this 5 ohm are in series, and this 6 ohm and this 3 ohm are in parallel. So we are going to solve this part of the equation first and then this one. So when we are solving this, we will see how the circuit is changed. So let's solve the problem. So let's solve this 1 ohm and this 5 ohm. So these two resistors are in series. So when two resistors are in series, we know the formula as R equivalent is equal to R1 plus R2. So when we are solving this, we will get as 1 ohm plus 5 ohm, that is equal to 6 ohm. And now we are going to solve this part. These two are in parallel. So it is, we know for RS is for series. In case of parallel, the formula actually it is 1 by R equivalent is equal to 1 by R1 plus R2, 1 by R2. So when we are solving this equation, we get R1, R2 is equal to R1 plus R2. That is 1 by R equivalent. So to get R equivalent, we consider it as R1, R2 divided by R1 plus R2. So now we are going to substitute R1 as 6 and R2 as 3. So 6 into 3 divided by 6 plus 3, that is equal to 18 by 9. So R equivalent is 2. So when we have found two values, now we are going to rewrite the circuit, redraw the circuit. So the circuit will be changing as this resistance will be the same, this 2 ohm will be the same, and here this two resistors combined together, a resistance will be found. So this will be a 6 ohm resistor. This is the existing 2 ohm. This is 4 ohm. These together will be formed another 2 ohm. And here another 8 ohm. We need to find R equivalent. So this circuit is redrawn as this particular part. Next we are going to solve. We are going to combine these two resistors. So we know R equivalent is equal to R1 plus R2, such that may be 2 plus 2, 4 ohm. So we again redraw this circuit. This will be 4 ohm. This will be another 4 ohm and a 6 ohm, and here 8 ohm. R equivalent to be found in this section. So we have already found this. I have already drawn, that is given in this diagram. Now we have already combined this two. So I told you how it is going to be changed. 4 ohm, 4 ohm, 6 ohm, 8 ohm, 4 ohm, 4 ohm, 8 ohm. Now we are going to solve this circuit. these two resistors are in parallel. So we know for parallel the formula is given as R equivalent is equal to R1 R2 divided by R1 plus R2. So R1 we are taking as 4 ohm and R2 as 6 ohm. 4 into 6 divided by 4 plus 6, that will be 24 into 10. So we are considering as 2.4 ohm. So this circuit will be redrawn as, we have combined these as 4 ohm and these two as parallel. So this will be combined as this diagram. See here, this. Now we have already found it's 2.4 ohm. So that both combined we have formed 2.4. Now all these three are in series. So R equivalent is given as R1 plus R2 plus R3, which can be written as 4 plus 8 plus 2.4. So R equivalent is equal to 14.4 as a whole. Sorry, it's not 8. So this will be actually as 14.4. Okay. If suppose they have given, for example, if they have given an voltage source here, a voltage source of 12 volt in the sense, or maybe 14 volt, what is the current in that particular resistance? How will you find it? So we know voltage is 12 volt and R equivalent is 14.4, and earlier we have discussed by Ohm's V is equal to IR. So I is equal to V by R. So it will be 12 divided by 14.4. For example, it is not given in the question, but I have